What is going on, ladies and gentlemen? In this video I will be going over what is a scalable system. This is another entry into my system design series. So yeah, we're going to talk about scalable systems, and as usual, the article for this video is in the description if you guys want to read everything that's in this video and some more. So the first question should be, what is a scalable system? What is scaling? Scalability is an important topic in system design. In modern day systems, usually a system is as simple as a client and a server, but as the amount of users increase on an application, the clients expect a reasonable response time, good or bad, within a certain period of time. Systems nowadays have to be able to handle millions of requests within a short period of time. Let's use Twitter as an example. Twitter has to be able to handle requests for authentication, retweets, shares, uploads, and so much more. I can't imagine Twitter just using one server to handle all these requests simultaneously. If there were just one server, either the response time would be really slow, or the server itself would just crash because there's too many requests simultaneously happening. The performance would be awful. This is where scaling comes into play. Scaling expands the current system to be able to handle more requests. Making a system scalable will save you time and a lot of headache. And trust me, as an engineer, you want to save yourself from headache. So there's two basic type of scalability. There's vertical scaling and horizontal scaling. So let's learn about them. So what is vertical scaling? Vertical scaling is when a user increases the amount of resource towards a server. So initially, say for instance we're using AWS, we might just use micro for a specific application, the smallest amount that the server needs, the smallest amount of resources that a server needs. But as the amount of users increase, you may want to increase the amount of resources that the server needs to run. So that means you may want to increase the amount of RAM that the server is using, the amount of CPU, and the amount of storage space. So you're increasing everything to the next level. That's why you see the little circle with the up sign. It's increasing the size of the server, increasing the resources that the server uses. So in short, the vertical scaling is increasing the hardware, which gives the server more power to handle extra requests that hits the server. Now, there are pros and cons to vertical scaling. The pros are there are more resources for a single server, which is great, right? More power for the server to execute what needs to be executed. There's lower cost compared to horizontal scaling initially, because you only have to deal with one server, right? One server, one license. And we're going to talk more about horizontal scaling in a little bit, but think about this when you learned about horizontal scaling. Just lower cost initially. Simplicity. There's little to no code change. You're only dealing with one server. You're increasing the resources. That's it. You only have to deal with just one server. Then there's flexible resources based on needs. Only increase what is needed. You don't have to increase everything. So if you just need more storage space, you can do that. But you can leave the CPU and RAM the same if you want to. But you have flexibility with that. But now there are cons, right? And you have to think about whether the pros outweigh the cons. So there is a single point of failure with simply just doing vertical scaling. Remember, it's just one server. So if that one server chooses to crash, you're done, right? You have to fix that one server, and while you're fixing it, everything is down because you only have one single point of failure. You only have one server. Also, because you only have one server, whenever there is downtime, like I said, whether it's a crash or if there needs to be any changes, such as like deployments, you will have to temporarily bring down the server or let the user know that the server is down during a certain period of time, which from a user's point of view sucks, right? If I need to use the application at a certain period of time and I'm seeing that there's an update going on, it kind of makes me not want to use it anymore, or I might not come back for a couple of days. Then there's restricted scalability, right? We can only make changes to one machine, right? So there is a limit to the amount of resources that we can upgrade the application to. So there's only a certain amount of RAM that we can increase it up to. That's not an unlimited resource, right? There's only a certain amount that we can go up to. There's only a certain amount of storage we can go up to. There's only a certain amount of CPU that we can go up to. It's not infinite. And remember, the more that we increase it by, the more expensive it gets. So that's also something that we have to think about. So those are the pros and cons, and these are things that you have to weigh in when making a decision on vertical scaling for your server. Then there is horizontal scaling. What is it? Horizontal scaling add more servers to distribute the load evenly among servers to handle the increase in traffic. So due to the nature of horizontal scaling, the initial setup may be difficult due to different factors, right? These factors include, handling the distribution of the traffic properly, using a load balancer, which we talked about in a previous video, or making sure that each server has the proper licensing. Remember, with vertical scaling, we only have to deal with one licensing because there's only one server, but with multiple servers, you have to deal with different licensing agreements for each individual server. So what are the pros and cons of horizontal scaling? Well, the first thing is it is fault tolerant, so it can handle different scenarios with ease. So say for instance there's an increase in traffic, you only have one server initially. With horizontal scaling, a new server is spinned up and traffic is routed to the new server. Or say for instance a server is down, that means all of those requests that was going to the server that is down will go to the new server, and now we have a fault tolerant system. Also, there is an increased performance. So like I said, if the more servers, the better it is, because that means requests are going to be evenly distributed, meaning the performance is better. There's more connections, more traffic can be handled. And lastly, there is no single point of failure. I know we talked about in vertical scaling, like we can increase the resources, but once that server is down, it's over. But with horizontal scaling, a failed server will point all new traffic to available servers. So there is no one single point of failure. Everything is distributed, and if one man is down, or woman, it is distributed to the next server, the next person. But in this case, we're talking about servers. And then the cons, right? Extra configuration is needed, so you will have to deal with a load balancer. You would have to deal with networking and routing, because all of that, you could always use services that does it for you, but if you're trying to do it manually, all that will have to be configured. The second thing is designing is more difficult. You have to handle how the connections are distributed, and there are different algorithms for that, and I talked about that in my load balancing article and video. But you have to handle how the connections will distribute to each individual server evenly, because there are different algorithms for that. And then there is the increased costs. Each server is a new cost. It's not free. We already talked about licensing, and much more, because each one of those servers have resources that are being used. So increased costs initially, but in the long term, depending on how big your application is, you may end up saving money, because increasing the RAM, increasing the CPU, and all those other resources in vertical scaling to a certain point, maybe even more than just doing horizontal scaling. So some math will have to be done for that as well. So which one is the best choice? Well, to me, there is not a single best one to choose. It is dependent on the situation, like I just discussed. If you need a temporary boost of resources that can be changed or scaled back, you can use vertical scaling, right? You can adjust it based on the resources that you need. So you may want to reduce the amount of storage, the amount of CPU being used. But if you have an application that has a lot of services and have sporadic traffic, high and low, like you never know how many users are going to come. Maybe you might have a peak time at 3 p.m. with millions of users or thousands of users, but then a couple hours later you only have like 1,500 users. Then you might want to think about horizontal scaling, because with horizontal scaling, it can scale based on, or there's algorithms that will scale the amount of servers based on the amount of traffic that you have. So I would just say, think about it, do your research, and choose the one that's best for you. Money is important upfront. Upfront horizontal scaling is expensive, but over time, vertical scaling can be more expensive, like I just discussed, because of the nature of hardware and cost of the hardware. If you do not believe your application will require like a major upgrade, and you don't care about having just one single point of failure, then maybe vertical scaling is for you. But that's another thing. Is the owner okay with just having a single point of failure? Or do the owner wants the application to be more fault tolerant? Most people will say they want the application to be more fault tolerant, which means horizontal scaling will probably be a better choice in that regard. You have to think about the future. You have to think about whether the application will be growing, or whether you chose a specific niche that you don't expect too many users to use the applications. You only expect a certain threshold. But if scalability is a factor, I will also recommend horizontal scaling, even with the headache up front with the connections and getting everything set up. So, like I said, I can't make the decision for you. Think about the pros and cons, And both type of scaling have their thing that is good for. Think about the future as well. Don't think about just right now. So hopefully that was helpful. Now, if you enjoy all of that, go ahead and leave a like, subscribe, and I intend on making more system design videos. I believe just getting a basic understanding of what everything is pretty important. So hope you guys enjoyed that.